Welcome to the lesson Determining Density. In this lesson, you will explore the densities of various substances. Throughout history, people have dreamed of overcoming gravity to fly or float through the air. The first recorded manned takeoff of an airborne vehicle happened in France in 1783. This vehicle was not an airplane with an engine. It was a hot air balloon. The scientific principles that allow hot air balloons to float through the sky are simple. In this lesson, you'll learn about some of these principles and see them in action. One key concept is density. Iron is denser than wood because a certain volume of iron has more mass than the same volume of wood. The density is the ratio of its mass to volume. It is expressed in the following formula. Density equals mass divided by volume. The mass of 100 cubic centimeters of water is 100 grams. Use the formula to calculate its density in grams per cubic centimeter. Enter your answer in the box, then click OK. The density of water is 1 gram per cubic centimeter. Density is determined by two physical properties, mass and volume. It is a characteristic physical property. Unlike mass and volume, the density of a substance does not depend on the amount of the substance. How will you calculate the density of a solid object? You will need to know its mass and its volume. You could use a balance to measure its mass. Drag the piece of iron to the balance. Record the piece of iron's mass in the table. Drag the cork to the balance. Record the mass of the cork in the table. Now let's measure the volume. It's tricky because the objects have irregular shapes. However, you can use a method called displacement. Here's how. Click the beaker to select it. Drag the piece of iron and place it carefully into the water. The water level increased by 5 cubic centimeters, so this is the volume of the piece of iron. Record the volume in the table. Some solid objects, such as a cork, float on water. It must be held underwater for its volume to be measured. Drag the cork to place it carefully into the water. We will use the pin to hold the cork underwater. The water level increased by 5 cubic centimeters, so that is the volume of the cork. Record it in the table. Now calculate the density of the cork by dividing its mass by its volume. Calculate the density of the piece of iron. Record its density in the table. You should have found that the density of the cork is less than the density of water and that the density of iron is greater than the density of water. Do you notice a connection between the object's densities and how they behave in water? A substance with a density less than water floats. An object with a density greater than water sinks. To take another look at the evaluation of density, here is what you'll use. 5 different liquids with different densities that don't mix. A cylinder. A liquid density table. You will be able to use the cylinder to compare the densities of the liquids. The water and paraffin oil have been colored so that you could tell them apart. The water is red in this experiment. You'll run an experiment to evaluate the density of a mystery liquid without measuring its mass and volume. You have 4 liquids whose densities that you do know. All 5 liquids always separate from each other no matter how vigorously you mix them. Can these items help you to evaluate the density of the mystery liquid? How? Record your hypothesis in the box, then click OK. Continue to test your hypothesis. Describe your plan about how to use the liquids and the cylinder to evaluate the density of the mystery liquid. Pour the liquids into the cylinder successively. Begin with the densest one first. Add the mercury to the cylinder. Add the aniline to the cylinder. Add the water to the cylinder. Remember that the water has been colored with red food coloring. Add the paraffin oil to the cylinder. Now add the unknown liquid. Wait for the liquids to settle. When you've finished, click the next button to go on. Analyze your results. Look at the position of the mystery liquid in relation to the other liquids. What can you conclude about the density of the mystery liquid? Type your answer in the box, then click OK. If you look, the mystery liquid fell between the paraffin oil and the water. Therefore, its density must be between 0.88 and 0.998. The liquids settle according to their relative densities. The densest liquid is at the bottom, and the densities of the liquids decrease as you go up. The mystery liquid settled above the water layer and below the aniline layer. Therefore, the mystery liquid must be less dense than water, but more dense than oil. Its density is between 0.088 grams per cubic centimeter and 0.998 grams per cubic centimeter. You can use a similar method to estimate the density of the solid object. Drag the mystery solid into the cylinder and wait for it to settle. Observe the resting position of the mystery object. What can you tell about the density of the mystery object? Click the cylinder to discover more. You can see that the mystery object settles between the mercury layer and the aniline layer. Therefore, its density is between 13.53 grams per cubic centimeter and 1.022 grams per cubic centimeter. Notice that the object is halfway between the mercury layer and the aniline layer. This indicates that its density is approximately 7 grams per cubic centimeter. What other substance in this lesson had a similar density? So, what do hot air balloons have to do with density? Well, the density in the air in the atmosphere is not uniform. Every layer of air compresses on the layers below, making the layers denser towards the bottom. The end result is a bit like the layers of the liquid in your cylinder. Air, like all gases and most materials, expands when it is hot and becomes less dense. Like our mystery object, the balloon will settle at an altitude where its average density is equal to the density of the surrounding air. Great job! You've learned a lot about determining density. Before we finish, let's take a quick look at the main points you covered. Density is the ratio of mass to volume. The density of an object compared to the density of water determines whether the object sinks or floats. Liquids that don't mix and have different densities separate into layers according to their relative densities. Relative density can be used to determine the approximate density of an unknown material. Now that you've finished the lesson, click the lab report button or save to print it.